Can one of the oldest and most persistent problems in all of video games be solved by looking at the way three different surface types respond to a single condition? Basically, yes. The condition is whether or not a straight vector can travel from the game's avatar directly to any of three types of game surface. The first type can be thought of as the surface of a sphere that has the game's camera at its center, with the distance from the camera's focal point to the game's avatar is equal to its radius. And the last two types are simply the distinction between the front and back side of any collision map geometry within that sphere. An array of vectors are cast outward from the camera's focal point to where they intersect the sphere's surface, and the camera system determines whether or not to draw a solid pixel at that point based on whether or not a straight vector can travel directly from it to the avatar without crossing any other solid planes. So basically, whether or not it is meeting our main stated condition. If there is a direct path, the pixel isn't drawn, and if the vector is interrupted by any other piece of collision map geometry, the pixel is drawn, and the player won't be able to see into the game world any further than the sphere. Any geometrical surface within the sphere that is not the sphere itself is also tested by the main condition, but meeting it or not will have the opposite effect on whether or not it is drawn, in which case an interrupted path to the avatar will result in an undrawn surface, but an uninterrupted straight path to the avatar will result in a drawn surface that's lowered in opacity as it gets closer to the camera if it's the side of the geometry facing the avatar. But if it's the back side of that geometry facing away from the avatar, it should be instead drawn as a textureless halftone pattern comprised of elements that get smaller as they get closer to the camera. This process can be thought of much in the same way as occlusion culling, except that it's altered to operate from the avatar's perspective. And that's all it would take to functionally fix 3D camera systems for third-person games with complex movement mechanics. Of course, there are a lot more effects that could be implemented in order to clear the performative bar set by the ingrained biases of the average gamer's learned expectations for how a camera should behave. But with the simple protocols set out here, the camera could go anywhere within or outside of the game world's boundaries, and so long as the avatar is still within its limits, the image the system would composite would graphically make sense in a way that's always legible to the player.